Hi. How many distinct positive integer valued solutions exist such that this whole expression is 1? So now this expression that we have is of the form a to the power b is 1. Now when you have a base to the power which is 1, this is possible in 3 cases. What are these 3 cases? First, that the base is 1. So 1 to the power any number. B can be any real number. So if b is any real number, 1 to the power any real number will be 1. The other possibility is that the power is 0. So any real number to the power 0, a and b are both distinct integers. So as long as a is not 0, base is not 0. So any non-zero number to the power 0 will also give us 1. The other possibility is that if a is 1, that the base is negative and b is an even number. In that case, minus 1 to the power an even number will always give us a positive value. 1 will always give us 1, right? So these are the 3 cases that we need to consider. Case 1, when base is 1. Case 2, when the power is equal to 0. And case 3, when the base is minus 1 and the power is a even number, right? So let's look at each of these cases. The first case, if base is 1, the base here is x square minus 7x plus 11. Now if we have x square minus 7x plus 11, this has to be equal to 1. So we have x square minus 7x plus 10 is 0. Now this is a quadratic equation and we have to figure out the roots. Since it is equal to 0, we need to figure out the roots. And if you use splitting the middle term, you think of two numbers whose product is 10 and the sum is minus 7. So the numbers will be minus 5 and minus 2. So we have x minus 5 into x minus 2 is equal to 0. So we have two values here, either x is equal to plus 5 or x is equal to plus 2. Either this is 0, that will give us x5, or this is 0, that will give us x equals to 2. So we have two values of x from here. So we get two solutions of x here. Next is when the power is 0. The power is this. So we have x square minus 13x plus 42 should be 0. Now again this is a quadratic, so let's try to factorize this. Think of two numbers whose sum is minus 13 and the product is 42. The numbers will be minus 6 and minus 7. So we can factorize this as x minus 6 into x minus 7, which is equal to 0. Now the product of these two numbers is 0. So either x minus 6 will be 0, that will give us the value of x as 6, or x minus 7 will be 0, which will give us x equals to 7. So from here again we have two possible values of x. And finally we have this condition, base is minus 1 and the power is a even number. So this is the base. Let's check. The base x square minus 7x plus 11 should be minus 1. Bringing minus 1 here, we get x square minus 7x plus 12 is 0. Now can you think of two numbers whose sum is minus 7 and the product is 12? The numbers are minus 3 and minus 4. So this can be factorized as x minus 3 into x minus 4 is equal to 0. And from here we get two values of x, 3 and x, 4. But we don't have to stop here. We have to check whether the power is even or not. So when we check for x equals to 3, what is the power here? X square minus 13x plus 42. So 3 square is 9, minus 13 into 3 is 39 plus 42. So 9 minus 39 is even and this is even. So the sum will come out to be even. This whole expression comes out to be even. So this value is acceptable, x equals to 3. Okay. And what if x is equal to 4? When x is 4, 4 square is 16 minus 13 into 4 is 52 plus 42. So here we have all the terms are even. So the sum will definitely be even, right? So if the sum is also going to be even, that means this is also acceptable. We wanted power to be even, right? So from here also we'll get two acceptable values. So how many acceptable values we get total? How many distinct acceptable values? We have 2, 3, 4, 5, 6, 7. All of them are distinct. So you'll get total of 6 acceptable values for x. Option D is the right answer. Thank you.